Hello and welcome to the relighting discussion. We are inside of Fusion and we'll walk through this script here from left to right, and we'll go through most of these nodes, not all of them but quite majority of them, to make sure that we talk about relighting itself and also some projection work that is different than the projection work that I have done in the past. And then we'll come down to the rendering before we start to look at these scripts here. Okay, so let's jump in and look at the very first thing, which is the video that we had taken using the camera. So this was brought inside of Synthesize that you saw, and in Synthesize we basically created this camera, and this camera is moving exactly how I was moving with the handheld. And that's the result of tracking inside of Synthesize. In Synthesize we also were able to generate this point cloud, which gives you the perspective of the 3D space as to how things are laid out. The wall, for example, it's right here, and if you look at this scene node here, you have the camera here, and you can see how far the camera is from the wall, and there it goes. Okay, so let's start simple here. Let's bring in an FBX model or see how it was brought in. This one here is just a very simple lamp. This was created inside of Maya, and I brought that in using this workflow here. Import, let's detach this, and 3D scene, and you have all these FBX models that I created inside of Maya. And you just select the one that you want and you bring it here. Now this one was not placed properly inside of Maya, so when it came in it was still at 000 space right here, but that's not where I wanted it. So what I did then is just use this point cloud to position the lamp exactly how where I wanted. Now I just did it by hand, but what you can also do is take any point. Let's say that this is the point where you want the lamp to be. You can right click on the point and publish it, and once you publish that, and I have done a few of them, and you will see as soon as I go there, what happens is that tracker is now right here with this data, and the coordinates that you see here are the exact position of this point in 3D space. So what you can do then is just take the coordinates of the 3D geometry and apply it exactly what you have here. So I would just select this, and then I would control select my FBX, bring it here, and look at the location and rotation if I need to, but most importantly location of this FBX model, which would have been 000 when it came in. And then just take these values and apply into this X, Y, and Z, and that's how you would get this lamp here. So if you just look through the main camera, you can see that the lamp is where it's supposed to be, just about the plate. Now pay no attention to the stem here that you see in the back. You will not see this at the end because we have not created the wall yet in terms of 3D geometry, and as soon as that comes in, this will go away. So just to demonstrate that, let me just bring the wall here, and don't pay attention to the lights, but now you see that the stem went away because this wall here is now getting in the way of the stem. So if you look at the 3D or the perspective view, you see that the stem is now behind the wall. Alright, so let's go back to, I'm going to close this. Let's go back to this scene here. Right, so there is nothing we have done here that is super complex. It's just bringing of geometry and just placing it at the right place. Now we have a bunch of projection work here, and we'll just take a look at one because most of them are following the same methodology, and if you do one, then I think you will understand how it was done. Now let me come here and take this projector out. So this is how the camera is moving, and this is how I want to project the image or the texture on the FBX, which in this case, if I take this catcher tool out, you see that it's a house, and this house is positioned exactly where this house is in the back that you see, and I want to have a texture of this house, what you see here, projected on here. Now if we use this camera, the problem is that the camera is moving, and so is the texture, so we can't really use this. If you try to do that, let's just do that anyway. I'll just copy and paste here, and we'll use this as a projector. I'll just apply that here, and I'll call this a projector, and image, we don't want to see the image, and this projector is going to be a texture projection, and I'm going to give it an ID of 99 just as a temporary ID, and also this catcher I'll call this 99 instead of 9. Now let me apply this catcher onto this blinn node, and now you can see that the texture is applied. But because this camera is moving, what will happen is that as soon as I go around, you will see that the texture itself is sliding on this geometry, and that's not what I want. I want the texture to be static, and to do that I need to do two things. One, I need the image that I want to apply as texture, not the image sequence, so I will need to isolate the image that I will use as the texture projection. And the second thing is the projector itself. I'll have to make this a static frozen camera rather than a moving camera. Well, that's pretty simple. You just go to the coordinates here and you see all this animation. In fact, if you just move, and you can see that the values are changing. So this camera is animated, and that animation comes from Synthesize. So you just right click here and say remove all from the translate group, and then also from rotate group, and now there is no motion here. So now if you look at the timeline, and if you go, now you see that one camera is moving but the other one is stationary, and this is the projector now, and that projector is now projecting something that is on here. Now the problem is that it's still sliding, and it's even worse now because the image sequence is shifting. So we need just the first image, because that's where the projector is located. The very first image, we need to isolate that, and that we will use as the source of projection, and that's exactly what I have done here. So let me just delete this, and we don't need this. This one is still 9. I'll call this 9 instead of 99, and let's just bring this one in. Now you have the projection here. Now the only difference is that when you go through the timeline, the texture is not shifting like it did just a minute ago. So now you have textured that building. Now what I did also, just to change the environment, I have this image of snow, which I applied some erasing to it using the paint node, and to randomize, you know, how the snow would look like, and then merge that over this image, which is coming in as the projection texture, and then applied that onto this camera. Now I don't worry about this part here. I mean, you can isolate that, you can do a mask here and just isolate the house, but because I'm using the projector ID, this picture, this image is only going to be applied on an FBX or any geometry that has the same projector ID, and there is going to be only one. So this one is 9. There are no other catcher tools that I have used here that has 9 as the projector ID. So I don't have to worry about overlapping of the rest of the image. Right, so so that both of them go into this merge node, and that finally comes in here, and that's what you see happening. And you see that this camera here is static, and that's the projector. As you go across, you will see that I have used multiple projectors with the similar methodology. Now you have 3 here, as you can, well, 3 cameras, 1 is dynamic and 2 projectors, and that is projecting texture on this building. Now it's not showing up because it's not connected here right now, but once you do that, and if you go back to the main camera and look at that, now you have this side of the building is covered, but the other side is not covered, and that part is coming through the different pipeline here. So if you come here, now you have that also covered. So I have used different projectors and different images from the image sequence using the same camera but freezing it at a certain moment in time and build the entire scene. So if you further go down all the way towards the end, just to drive the point here as to how many different projectors I ended up getting in, you see that over the path of the camera, which is the camera that goes from one end to the other, if you just go and see how this camera is moving, I have used all these different projections throughout the project. So you have many projectors taking a piece of the image or image sequence and projecting on different geometries. And in there you also have this wheel here. Now in the original footage you have seen that the wheel was actually rotating. What I did, I brought in the wheel FBX, which is not moving, and then I applied the texture from a particular moment in time where the wheel was in a certain position and projected that onto this geometry. So now you only have that one single image showing up throughout the shot, similar to the building that I just showed you a minute ago. And that way it's frozen. Now the only thing was that the wheel is not covered entirely in one or by one camera. What I mean is that if I look at the very first frame here, you have the wheel up to this point is covered, so you can see this part of the wheel. As you go further down, you see that the bottom part of the wheel is becoming visible. So I needed 2 projectors, one to cover the image from the top and the other projector to cover the image from the bottom. Now because we have a relatively good tracking here, it didn't really matter. I could combine both of them and it would still look like a one continuous image. I'll demonstrate that in some other work that I have done for the wall, because the same thing is happening for the wall. If you look at this wall, the wall is getting cut off right here, but if you look at the last shot, you need to see the bottom part of the wall, including this rock. So I needed to have 2 images. So this is the first image, which I used as the source of projection on the wall. It's a static still pose. You can see that it's not moving as I'm going through the timeline. And then I used another image here, which is most likely the last one, and I used that for the bottom part of the wall. So what I did is I used the very simple masking technique to isolate just the wall, and in this case I used the masking technique just to isolate the bottom part of the wall, and I just applied some soft edge so that it doesn't really become very harsh when you combine with the other image. So what happens here in a case like this is you have a wall, and I'll just bring this node here first. What you have here is an FBX. In this case it's not FBX, sorry, it's actually just an image plane that I created inside of Fusion. And here is another one, and these 2 image planes are capturing the respective images of this wall. So this image plane here is taking image of this wall, and then the other image plane is taking the image of this wall here, the bottom part of the wall, through respective projectors. So you see these 2 projectors, they are doing their jobs by taking the image this image and projecting in different places. As you can see, as I'm scrolling, nothing is moving because at this level here no camera is in motion. Now if I go one level down, let me just disconnect this light here. We don't want to see that yet. Now you see all these different projectors that are coming through the pipe here, but more importantly you also see the camera that is moving, right? So back to this node here for a minute, and I'll just go ahead and connect this light because we're gonna see that light in a minute. Right, so you have the projection here. Now beyond projection there are a couple of other things happening here. We already have the lights, right? So these lights are coming from up here. You have two lights here, and if I just disable one, you can see, and you can see that this is the yellow light here. So if I disable, that light goes away and you don't see anything because there are no other lights. And then the other light obviously is this white light, and if I disable that, you see that that goes away. So we have two lights that I have included in this node here, in this scene node, and placed them exactly where I wanted them. Now that's not the exciting part. The exciting part is how do we align the image, both images, and their respective bump maps, so that when you see this light coming through from your regular camera, your main camera, you will see the effect of the light, which you can also see here, that the top part of this cement here that is brighter than the bottom part. So how do you achieve that? And definitely you need bump map for that, and you can do all of that inside of Fusion. It's very simple. Let's just focus on that for a minute, and we'll go node by node here. So you saw this image that is coming into don't mind this paint node. There is nothing really happening there, but it's coming through the paint node into this projector, which is then projected onto this geometry. So that part is fairly simple. And if I just focus on that, and let me just get this bump map out, and also disable this UV map, because those two we need to talk separately. You get a very flat version of the scene that you were looking at. Now if I go up to the light here and increase the intensity, just so that you can see what's happening with the wall. You have the wall here, but it just has a flashlight onto the wall. It looks like there is no respect for all the work that is done on this wall. So there is all this cement and everything that's there, the rough edges of the stones. You don't see any effect of that because there is no bump map. So the first thing that you would need is the bump map. So let's bring this bump map into this blinn node. Right now you have bumps, and the problem with this bump here is that it's not aligned. You see that you have the plate here, but the bump map for the plate is all the way down there, and that's because this image is coming in straight through brightness and contrast, because what I had to do is just bring that down to black and white, and it's coming into this bump node, which now you see here all this bumpiness, into this blinn node, and that is coming into this material or the shape, and that is what you see here. But nothing is telling this bump node to align this image with the image that is being projected from this camera. So we need a common denominator here. We need the projector to also influence where the bump map would be projected. Now there is no direct workflow for that you also create a projector for the bump map, but what you can do is create a UV mapping tool inside of Fusion. And let me just go to the planar mapping first, and then I'll make this enable. Now you have some sort of mapping going on for the bump map. So this node is trying to map the bump values according to what you tell this node here. So you're telling the node that use the planar, or you can say use the cylindrical. Well, that doesn't work, and planar doesn't work, frankly, because if you look at the alignment, it's not there. You know, you see the double images here, so that doesn't work. Cylindrical doesn't work, spherical doesn't work, this cube map will definitely not work, XYZ to UVW will not work. Then you have this thing here called camera. So let me just remove, well, actually we don't have camera here, so let's jump in here and say camera. Now if I remove this camera for a minute, now what you have here is a direction to this bump values through this UV mapping that tells Fusion that you will use a camera to project the bump and everything that's coming down the pipe here according to how this camera is looking. So what happens is when you go from planar, and you see here that there is nothing for the input of the camera, but as soon as you click on camera, you have an input open here, and once you connect this camera that's incoming, that's the camera that you want to use, because that's the camera that is projecting the image. So you want to align the image and the bump map together. So use the same camera, apply it to the UV map tool, and you have the perfect blend. So now you see that all these color values that you see here is exactly how the bump map is also coming in. Now this may be a little bit exaggerated, so you can actually go into the bump and reduce the bump height, right? So as you wish, you can reduce the bump height. What you can also do is play with this brightness and contrast tool to decide what kind of bump do you want to see. And as you go ahead and change the values, you will see that the height will be impacted, because it is the black and white contrast that is impacting the peak and the valleys, if you want to call it, inside the bump. So just to see that, if you look at this bump map here, now if you go to the brightness and contrast tool and say you want to change the values, you can see that the bump is changing in terms of the height, and you can make it very shallow or you can make it very pronounced. But that's the additional control that you get by introducing brightness and contrast in this workflow. Right, so that's the way this wall is created, and as I mentioned, there are two of them. So you have the first one that is just taking the upper part of the wall, and then the second image coming from this route here is the bottom part. Now there's something that is missed. You can see that this rock here is quite flat, and that's not how the rock was. It was quite a 3D coming out at the camera. So what we will do in the next video is use this tracker here to create a shape to cover this rock, and then you will see how different it looks because of the light coming from the top, and now the light is going to hit the top of this rock, and you will have a very good representation of this rock in that case. Right, so we'll look at that next, and then we'll jump onto this fire to see how this fire was built and some of the other light work here. Thanks a lot.